Hello friends. In the previous lectures, we have discussed refraction through a rectangular glass slab, and we noticed that the emergent ray was parallel to the incident ray, but it was displaced laterally. Now we know what is refraction, that whenever light travels from one medium to another medium having different densities, then light gets refracted. And we also know that when light travels from rarer medium to denser medium, or I can say optically rarer medium to optically denser medium, then it bends towards the normal. And when it travels from optically denser medium to optically rarer medium, then it bends away from the normal. So now let's discuss one more concept of refraction, that is refraction by prism. So prism, it's a kind of a triangular figure, but it's a three-dimensional figure. You must have seen pyramids of Egypt. So it looks exactly like the same. It has two triangular bases and three rectangular lateral surfaces. Two triangular bases and three rectangular lateral surfaces, and those surfaces are inclined to each other. Representation of prism looks like a triangle to you because it is 2D representation of a three-dimensional figure. As I told you that the surfaces are inclined, laterally inclined to each other. They are not straight, they are laterally inclined. Not straight, laterally inclined. So the angle between its two lateral faces is called angle of the prism. So this angle A, angle of prism. There is a special activity also by which you can find the angle of prism. So all these surfaces are laterally inclined to each other, but in some order. So most of the time you would find that you are having equilateral prism. That means this angle, they are 60 degree. So there is an activity by which we can find the angle of prism. Prism, as I told, it's a transparent glass. It's 3D shape, but it's transparent and is made of a glass. Now we know that glass is denser than air. So whenever light would enter, so now you can see here that light is entering via this route. Rays coming and hitting the prism at this point. So our PE is incident ray. Here NN dash is normal drawn to this face AB. Now you know what is normal. It is the perpendicular drawn to the surface. So here NN dash, if you see, it is the straight line being drawn perpendicular to this surface. And now as our PE is the incident ray, so the angle between incident ray and normal is known as angle of incidence. So this is our angle of incidence. As the ray is entering from medium air to the medium glass, and glass is denser than air, so light will bend towards the normal. So now you can see that this is our normal NN dash, and instead of going this way straight, it has bent. Okay. Otherwise, if there had been no refraction, then ray would have gone straight to H. As you can see that if we just extend this ray, then it goes up straight like this. But since it is experiencing refraction, so it will bend. It will not go straight. In fact, it will bend towards the normal. So it has bent. So now this EF, now inside this is complete glass medium. So when there is no change in medium, the ray will go straight. So that's why it is traveling straight distance till F. So our EF is refracted ray. See, most of the times we know what we are facing, and especially during exams, you know that this is refraction and it is refracted ray, but still by mistake sometimes people write reflected ray because sometimes there is confusion and this kind of, as both sound same, reflection, refraction. So there might be the cases when you often misspell it in the exam. So be very much sure that write refracted. And now again, since this is refracted ray, NN dash is our normal. So the angle between normal and refracted ray is angle of refraction. Now this ray is going straight till F. Now again, after this boundary, there is again an optically rarer medium, the air. So again we have drawn the normal mm dash to the face AC. So mm dash is again normal to face AC. So now, as you can see that if there had been no refraction, if there had been no change in medium, then it would have gone straight. As you can see, it would have gone straight, but since there is change of medium, this is our glass and this is our air, so it will suffer refraction. Instead of going straight like this, and this mm dash is our normal, what it is doing, it is bending away from the normal. See, it would have been like this, and here we have the normal. So instead of going like this, it is moving away from the normal because it is moving from denser to rarer medium. Our Fs is the emergent ray because it is emerging out of the prism. The one that goes in, incident ray. The one that suffers refraction inside, that is always termed as refracted ray, and the one that comes out is always termed as emergent ray. And now again, mm dash is the normal and this Fs is our emergent ray. So the angle between normal and emergent ray is termed as angle of emergence. The whole function is clear to us that we just have drawn those lines with dash which the ray would have traced those tracks if there had been no refraction. And also we have drawn the normals to the faces AB and AC with dotted lines. So the ray coming like this, PE, incident ray, it would have gone straight, but it is not going straight. It is experiencing refraction, so it is, and being NN dash the normal, it is bending towards the normal. And then after hitting F, the side AC, again it is going back to the rarer medium, and mm dash is our normal. So instead of going straight, and this is our normal, it is bending away from the normal. Now what we have done one more step here, is that okay, this is the thing we have shown that the ray would have gone if there had been no refraction, this path, this dotted line. If we extend this emergent ray backward, then we find that it is actually intersecting this dotted line, which is basically the track, the path incident ray would have traveled if there had been no refraction. So these two are intersecting at point G. So now here again we are getting an angle. Now this angle D is known as angle of deviation. So now you must have seen that in rectangular slab there used to be an incident ray, and then once it enters the slab it bends towards the normal, and then when it comes out it bends away from the normal. And incident ray and the emergent ray, they are parallel to each other. Just lateral displacement was there. But here it's basically the shape of the prism. Rectangular slab is basically a 3D rectangle. So all the faces of the slab, they are straight. They are not making any angles. They are not lateral, especially. Like we are not facing any slanted surfaces. But it's here, the lateral surfaces of the prism, it's the shape of the prism which is bending the emergent ray in this particular way. Now you can see that this is our incident ray and this is our emergent ray, and they are no longer parallel to each other. Now PE is not parallel to FS. It's clear from here. Basically, it's the prism which is making the ray bend at an angle to the direction of incident ray. We can conclude that this would have been the incident ray, this would have been the incident ray, and this is our emergent ray. So this track, this is the angle which is D, that how much the emergent ray bends due to this prism. And that's why we call it angle of deviation, that the ray has deviated from its normal track. So this is the angle of deviation, how much the ray deviates. Deviate means it goes off track, it changes its direction. So how much the change is there in the direction of the emergent ray. So it's the normal word that we use in daily language, deviation. When someone deviates when someone goes off track, not following the same path, changing paths. So here also our light ray is deviating. So this is the angle of deviation, and we can measure this angle of deviation by certain angle. So this is all for today. In the next lecture, we will study the topics of dispersion of light by the prism. Thank you.